Hello guys, welcome to GeeklyEDU. My name is Eddie, and today we will be talking about geometric series. Now, a geometric series is a particular case of an infinite series. If you remember, you can go you can go back and watch that video. An infinite series kind of looks like this, where a sub n is, can be anything. A geometric series, specifically, is going to look like this. Okay, so it's going to be a number r. So r is a real number to the power of n. And again, r can be anything. Now, one of the reasons why we create a special category for these series is because we want to be able to solve them to see, because remember, all series, they can either converge or diverge. So ideally what we would want is to be able to just look at a geometric series and be able to tell right away, oh, it converges to this number or it diverges. Now, I'm just saying the only requirement that I gave r, the only condition is that r is real. So that means that r can be, there are many options for r. If, for example, if r is 1,000,000, then the series is going to be, I'm going to have 1,000,000 to the power of 1 plus 1,000,000 to the power of 2, so on and so forth. This is clearly divergent. Okay? I'm just going to have massive numbers that are just going to get bigger and bigger and bigger. Now, what happens if, for example, if r is equal to 0? Well, then I'm going to have 0 to the power of 1, 0, 0 to the power of 2, 0, 0 to the power of 3. So this is equal to 0. So then, in this case, it is convergent. So then what we can see here is that for some values of r, it diverges. For some values of r, it converges. So we want to be able to figure out, to tell right away, like, oh, what if I look at this number? How do I know which one it's going to be? So the rule is going to be that a geometric series will converge if r, or let's say if the absolute value of r is less than 1. And I say absolute value, this means -1 less than r less than 1. Okay? So, this is as simple, like, this is it, guys. That's the rule. Oh. And it will converge to r over 1 minus r. So then here, very important note, guys. If you have a series whose counter starts at 1 to infinity of r to the power of n, if it starts at 1, then it converges to this. If it starts at 0, then it's going to converge to this. And this is key, because you will get both types of problems, and then what you need to do is just identify, oh, does it go to 0? Oh, does it go to 1? Okay? And you don't need to memorize both terms. We can do a very simple demonstration here. If I start at 0, this is the same as if I had r to the power of 0 plus, and then the summation from 1 to infinity. So all I need to do is remember one of them, because here I'm going to have r to the power of 0, so 1 plus r divided by 1 minus r. When I solve this, I get 1 over 1 minus r, okay? Which is the value that I'm giving you here. All right, so very important note, guys. Okay, need to look at this. All right, so now let's look at some examples. Let's do the one that I did in my previous video. So I went from 1 to infinity of 3, 10 to the power of n. So first thing I need to do, guys, you need to remember what the general geometric series looks like. It looks like this. So all I want after that sigma is a number to the power of n. Very easy. I use the properties of the series. Take the 3 out. And rewrite it like this. Remember, 1 is the same as 1 to the power of n. So now that I have this, I can compare right away and realize, oh, r is 0.1. Well, that's it. 0.1 is less than 1. So right away I can tell S of n is convergent. And it converges. 2. Remember, guys, if the counter starts at 1, we use this expression. So r divided by 1 minus r. So I have 0.1 divided by 1 minus 0.1. But got the 3 here. So 3 times all of this. And basically, we're going to get 1 over 3, which is the same as 0.33. That goes on forever. Okay? Very simple, guys. So remember, if we do it like this, we don't have to write down all the numbers, all the terms, kind of like graph them and try to study what's happening with the summation. Okay, let's do another example. Okay. Actually, let's do one starting at 0 to infinity of, let's do 2 to the power of n. Okay, so right away I can tell, oh well, in this case r is equal to 2. Okay, because I basically have this, the counter is a little bit different. So in this case, even like the moment you say, well, r is equal to 2 and this is greater than 1, right away, guys, divergent. Okay, the series will diverge. But let's say that you forgot. Okay, let's say that you forgot and you try to use the formula to see where the series would hypothetically converge to. Because it starts at 0, then this is going to be the formula I'm going to use. And then I say 1 over 1 minus 2. And this gives me negative 1 over 2. So here is where we see this is a massive problem. Why? Well, guys, because we're adding up positive numbers. We have 2 to the power of 0, plus 2 to the power of 1, plus 2 to the power of 2, which is the same as 1, plus 2, plus 4, plus 8. And then we're saying that all of this is equal to negative 1 over 2. Absolutely not. So then, very important, guys, whenever we have a number, we need to check if it's greater than or equal to 1. Now, what happens when it's exactly equal to 1? We'll do that in another video. Please like the video. If you thought the explanation made sense, please, even more important than liking the video, remember to pay attention to the counter so you can use the proper expression. So don't forget to subscribe, like the video, turn on the notifications so you can see when we upload a new video about math and different science topics. And yeah, remember, drop a comment if you have any questions about geometric series or basically anything at all. Have a great day, guys.